Okay, we are ready to move into Chapter 3, where we are going to discuss logarithmic and exponential functions, how to graph them, how to just manipulate them, how to solve equations involving them. But where we're going to start is by looking at the graph. And so, talking about logarithmic graphs, we have a general table for a logarithmic graph with any base b. Now I'm going to do some specific examples down below of common logarithms that we typically use a lot in our studies, but we're going to just start from this general table, and the y values for the logarithm are always fixed. So you are always going to have -2 ranging all the way to 2, and then the x values are going to change depending on what the base of the logarithm is. And so what we remember about the logarithmic function back in our discussion in Chapter 1 is that it has a vertical asymptote, and it's going to be difficult to see that, so you're just going to have to really know that, because remember, the logarithmic function is one of our functions that has a domain restriction, noticeably that you can't take the logarithm of a negative or a 0, and that's what creates our vertical asymptote. So let's get going here on this base 2 table. So for log base 2 of x, I know that my y values are fixed, -2 to 2, but for my x values, they're going to change depending on the fact that this is base 2. And so for my first x coordinate, that's going to be 1 over 2 squared, which is going to be 1/4. And so as best I can, I'm going to graph a point at 1/4 and -2. So 1/4 and -2, and I'm not even sure I can get this on here the way that I want to, but I'm going to try. And so there we go. How about that? 1/4 and -2. The next x-coordinate would be 1 over b, which in this case would just be 2. So 1/2 and -1 is where my next point is going to come. So there's my best effort there. 1, 0, so that middle x-coordinate is always fixed at 1, and then the next x-coordinate is b, and b in this case is 2, and then b squared, which is going to be 2 squared, which of course is 4. And so I'm going to plot those last couple of points. 1, 0 is right there, 2, 1 is here, and then 4, 2 is going to be here. And then, as I said, as best you can, you're just going to graph through those points and noticing that there's an asymptote at x equals 0. So going through the points, and then the graph will continue increasing in that direction, and that will give you your graph. And just so you know, like I said, there is a vertical asymptote here at x is equal to 0. Okay, let's take a look at some other common bases that we sometimes use. Log of 1/2 x, and then the natural log of x, which we'll talk about here in just a second. So for log of 1/2 x, here's what I know. I know that my y coordinates are going to remain the same. So my y coordinates are going to be -2, -1, 0, 1, and 2. And then my x coordinate is going to be 1 over the base squared for this first one. So in this case, the base is equal to 1/2, and so 1 over 1/2 squared is going to equal to 1 over 1/4, and anytime I divide by a fraction, I just multiply by its reciprocal, and so 1 times 4 is going to give me 4. And so I'm going to have the point 4, -2 to start off here, which is that point right there. Okay. The next one is going to be 1 over b, so 1 over 1/2, which is going to equal to 2, and so I'm going to plot the point 2 and -1, which is going to be right there. And then remember that this x-coordinate is always fixed at 1, and so 1, 0 is going to be on our graph right there. The next x-coordinate is b, and b in this case is 1/2, so I'm going to plot a point at 1/2 and 1. And then at the y coordinate where it's 2, I'm going to have b squared, and so that's going to be 1/2 squared, which is 1/4. And so at 1/4 and 2, as best I can, I'm going to plot a point there. So you can see this graph is also going to have a vertical asymptote at x equals 0, but instead of increasing like the previous graph that we did, log base 2 of x, this graph is going to be decreasing, like so. Okay, finally the natural log table. So for the natural log, very important fact coming here, for the natural log, the base of the natural log is the number e, and the number e is about 2.718. I could go into a lot more details about what this number means and what it represents and how we come up with it, but for now all you really need to know is that e is approximately 2.718. And so when we go to find our table here, we know that our y values will remain fixed, and then the x value for the first one is going to be 1/e squared. Now, no one's going to really expect you to have this decimal number memorized. I'm just going to tell it to you. It's 0.135. Okay, and again, no one really expects you to have that memorized. What I'm essentially trying to show you here is that the graph pretty much looks very similar to the first graph we did, which was log base 2 of x, and that should make some sense because 2.718 is not that far off from 2. So 1/e would be the next x coordinate, and 1/e is approximately 0.368 or so. Okay, the next coordinate I know is fixed at 1. The next coordinate is e, which is about, as I said, 2.718. And then finally, the last x coordinate will be e squared, which is going to be about 7.389. So again, don't really expect you to have those decimals memorized. I'm going to go ahead and plot these points so that you can see that this graph is going to look pretty similar to our log base 2 of x graph. So 0.135 and -2, that's going to be somewhere in this area down here. And then 0.368 and -1 is going to be pretty much just right above that point almost. And then 10 is here. 2.718 and 1. And then 7.389 and 2 is going to be down here somewhere. And so again, we're going to have this graph that has a vertical asymptote at x equals 0 and then increases in that direction. And so again, plotting these points particularly, not as important as you understanding the characteristics of the graph as far as domain and range and what it looks like. That's what I'm more concerned with in this particular section, not necessarily graphing these obscure decimals. I don't necessarily care about that part too much, but what I do care more about is that you understand what the graph looks like and some key characteristics of the graph, and we're going to explore that in the following examples.